Hello and welcome to BioRules video lessons. Today we are going to be talking about QuiSquare to try to check if the distribution of organisms happen with a certain association or if they happen by chance. So the question will be, are the species associated with other species? So here we have an example of a bunch of species that are maybe living close together, maybe living far away. We see that apparently the yellow ones are more to the right, the orange ones are more to the left. So how can we investigate this? One way is for us to try to put a grid with squares, quadrats, but not to count, not just to make the population, but in this case here to see if in each of these squares, if we have the orange species alone, if you have the yellow species alone, or if you have both of them together, or if you have none of them, so both of them separates. So if we check out over there, we see that there are three squares that we have both orange and yellow. We have four squares that have neither orange or yellow. We have 16 squares that we have oranges with no yellow, and we have 17 squares where we have yellows with no oranges. And the question is orange and yellow, the orange and the yellow species, associated with each other? Are they positively associated? That means when you have one, you have another one. Are they negatively associated? So when you have one, you don't have the other one. Or they follow a total random non-associated pattern. So how do we solve that? I'll get that same table where I have 3 with both together, 16 oranges, no yellow, 17 yellows, no oranges, and 4, neither of them. And I'm going to be adding the columns, so I have 19 and 21. I'm going also to add the rows and the columns, and I have the total, so I have 40 over there. For me to find out what would be expected by chance, if this was kind of random, what I do is to get the columns over there, so I add them there again, and what I'm going to be doing is for the expected yes and yes, so I expect for both of them, what do? I get the 19, so I get the total for that row, 19, I multiply by 20, which is the total of that column, and I divide by the overall total, which in that case is 40. So 19 times 20 divided by 40 equals 9.5. So if this distribution was happening by chance, it would be expected here that we had 9.5. So let's do for the other group. So for that one over there, what do? I do 19 times 20 divided by 40. So 9.5 again. And for that bottom one over there, what do? 21 times 20 divided by 40. So in that case, 10.5. So in this case, it would be expected by chance 10.5 organisms. And this here is going to be the same, because it's going to be 21 times 20 divided by 40 is going to be 10.5. So if these two organisms were distributed by chance, with that distribution I have on the left, the expected ratio would be this 9.5 of the squares should have both, 9.5 should have only oranges, 10.5 should have only yellows, and 10.5 should have neither of them, so it should be blank in this case because we only have those two species. But we didn't find those numbers. We got numbers that are slightly different. So how do I compare to see if these numbers here, the observed values, actually these numbers here, the observed values, are matching with these numbers here, the expected values? For that, I do a QuiSquare. So the QuiSquare is going to be comparing the observed and the expected. And the formula for the QuiSquare is this, is the sum of the observed minus the expected to the power of 2 divided by expected. So let me show you this here with an example. Observed 3 minus expected 9.5 to the power of 2 divided by the expected, which is 9.5. When I solve that, I'm going to get minus 6.5 to the power of 2 divided by 9.5, which equals 42.25 divided by 9.5, which equals 4.45. So this is one of the numbers. Keep that number over there. I have to repeat that for every single of the squares I have there. So now I will do there with the 16. 16 minus 9.5 to the power of 2 divided by 9.5. So again, 6.5 to the power of 2 divided by 9.5 is going to be the same value, 4.45. Keep that number over there. Let's do another square now. So now I'm going to be using that one there on the bottom left. 17 minus 10.5 to the power of 2 divided by 10.5. So this is going to be 6.5 to the power of 2 divided by 10.5, which equals 40.2.25 divided by 10.5, which equals 4.02. And if I do that for the last one in the bottom right, it's going to be 4 minus 10.5 to the power of 2 divided by 10.5. So it's going to be minus 6.5. So the value is going to be the same. This is going to be 4.02. The chi-square is the sum of those values. So I'm going to be summing, adding this, 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 and this. So that's going to be the chi-square, the sum of those values. So in this case, it's going to be 16.94. What this number means? This number alone, it means not much. So I need actually to take a look on a table that you have critical values for chi-squares, where I can check to see if this difference between observed and expected is happening by chance or not. So if it's matching the expected or not. So there I have the values again, and here I have a table with critical levels. My chi-square is over there, 16.94, and I will calculate the degrees of freedom. Degrees of freedom is the following: number of rows minus 1 multiplied by the number of columns minus 1. In this case, 2 minus 1 times 2 minus 1, which equals 1. So I will go there for that line, which is the 1 degree of freedom, and then I will check to see. My hypothesis says that observed is different to the expected. So there's a chance that I'm wrong when I say that. So am I wrong when I say that? So the chance that I am wrong is over here. 16.94 is in this corner over here. So it's beyond that value. That means that the chance that I am wrong is smaller than 0.05, which means it's smaller than 5%. So the probability I'm wrong when I say observed is different to the expected is less than 5%. That means that the observed is different to the expected. It's not matching. So 5% over there. So my observed is different to the expected. So I confirm that whatever I observed here is not matching what was expected over there. So what does that mean? That means that there is an association between these species. These species have an association. So they are not there just randomly around that space. So which kind of association is that? Is it a positive association or is it a negative association? Positive association is when I find one, I find another one. Or if I don't find one, I don't find the other one. Which is not the case here. What I have here is that below the expected, I have the both together or both separate. This is happening less than expected. So this is not a positive association. What's happening is that I have more than expected of them separate. So this here is a negative association. That means if I find one, it's unlikely that I'm going to be finding the other species in that place. Okay? So there. Okay. Those numbers are bigger than expected. That means that I have, in this case, a negative association. If I find an orange, it's unlikely that I find a yellow together. If I find a yellow, it's unlikely that I find an orange together. Okay? So, negative association. Let's take a look on another example. Okay? I will get here another example, same little orange and yellow balls. I will make my grid over there, and I will count. How many do I have them? Only the oranges, 5. How many I have only the yellows? 7. How many I have both of them? 13. How many I have them? No, none of them. 15. So let's calculate the chi-square. How do I do that? I add the lines, I add the columns, I get those values over there, and I'll make here a table for expected. So my table for expected is going to be 18 times 20 divided by 13, which equals 9. It's going to be 18 times 20 divided by 40, which equals 9. No, 22 times 20 divided by 40, which equals 11. And 22 times 20 divided by 40, which equals 11. These are my expected ratios. Okay, you see that at this time, the values are a little bit closer. Now we have 13 instead of 9, you have 5 instead of 9, you have 7 instead of 11. So there's a chance that maybe the chance here by random, the observed value here may not match the expected value by chance. So we do the chi-square over there. Observed minus expected to the power of 2 divided by expected. So I have 1.78 for the first column, which is going to be 13 minus 9 to the power of 2 divided by 9. Then I have 1.78 for 5 minus 9 to the power of 2 divided by 9. Then I have 1.45 for 7 minus 11 to the power of 2 divided by 11. And I have again 15 minus 11 to the power of 2 divided by 15. No, sorry, by 11, because it's 11 expected. So when I add those, I have a number which is 6.46. What that number means, okay? With 1 degree of freedom, because I have two columns here, 2 columns minus 1, multiplied by 2 rows minus 1, so 2 minus 1, 1, times 2 minus 1, 1, so 1 degree of freedom. And I take a look on that table over there at 1 degree of freedom. So my number here is 6.46. 6.46 puts my p over there. So basically, my p is in between 0.02 and 0.01. That means my probability is smaller than 0.02, which is smaller than 0.05, which is the critical value. The critical value here is 3.841. So if my chi-square is over here, is in between 5.412 and 6.635, and 6.46 is just over there, that means that my p, my probability that I am wrong when I say that the observed is different than expected, it's smaller than 0, when the chance I'm wrong is smaller than 0.02 or 2%. So in that case, I can say that the observed is different to the expected, because the chance I'm wrong is very small. If the observed is different to the expected, now we have to check out to see which relationship do we have. So we have more here, where we have both of them or none of them, then we have on the expected by chance. And we have less of them alone than we would expect by chance. So in this case here, this association is a positive association. If I find one, I will find the other one. If I don't find one, I don't find the other one. Okay? Very good. This one I will wait for you to do yourself. So you will pause the video while you're doing. So you have all this. I'll make the grid for you. I'll make the table. But you're going to be filling up yourself in a little piece of paper by your side. So how do we do that? I'm going to be putting here my little grid so I can check. And you're going to be counting how many I have both of them. So orange and yellow. Count it out. How many I have only orange, no yellow? How many I have only yellow, no orange? How many I have none of them? So pause the video and count, and I'll wait for you when you unpause the video after you count those 4 possibilities. Okay, now that you unpause the video, let's check it out how many we have over there. So I'm already putting all the values over there. So how many I have both of them together? It was 6. How many I have none of them? It was 10. How many I have only orange? It was 12. How many I have only yellow? It was 12 as well. So now we have those values. So what I want from you now is for you to calculate the expected values. How do you calculate the expected values? You add the total of the row and the total of the column. I'll pause the video, add the total of the row and the total of the column. I'll wait for you. And then you unpause the video and you have just calculate the total of the row and the total of the column. Okay, you've calculated, so let's see if you got right. So the total for that row is 18, for this one is 22, for that one is 18, and for this one is 22. And the total is 40 again. I'm always using 40 here to make your calculations easier. So what are you going to be doing now? Now you're going to be finding what is the expected values for each of those four scenarios, both of them together, only orange, only yellow, and none of them in the square. How do you do that? Multiply the total of the row by the total of that column and divide by the overall total. So do the calculation for the four of them. When you finish, you unpause and we will check if you calculate correctly, if your calculation is matching with mine. Okay, you have unpaused, so you have done the calculation. Let's check it out. So for this one here, the expected value was 8.1. I rounded it. Okay, it's 8.1. And here 9.9, and here 9.9, and here 12.1. Those were the expected values by chance. So if the distribution is random, if there is no positive association, that's what would be expected by chance. So check it out. Is your calculation matching? Yes? Good. If it's not, check out to see where you got wrong, to see what you can do to fix it next time. So what we're going to be doing now, you calculate the QuiSquare. So for every of those squares, you're going to have one observed minus expected to the power of 2 divided by the expected. So you will pause the video now and you calculate the four values, one for each of those, and then you add them, because the QuiSquare is the sum of the observed minus expected to the power of 2 divided by the expected for each of the four scenarios. So pause the video. When you finish, unpause and check out with my calculation. Okay, you have already calculated, so let's check it out. So 0.54, I'm rounding again, but I'm rounding for 2 decimal places. That's probably going to be enough. Okay, 0.45, 0.45, and 0.36. If I add those, I get 1.80. By the way, if you round to 2 decimal places, and when you find your value for QuiSquare and it gets very close to the critical value, to the value there around 0.05, then maybe you have to increase 1 decimal place to make sure that you know where you stand. Okay, but I don't think that's going to be the case. 1.80, so what I do now, degrees of freedom is 1, because I have 2 columns minus 1 times 2 rows minus 1, so 1 degree of freedom. So I'll check out that on the table. And now you tell me, is the observed matching the expected? My hypothesis is observed is different to the expected. But when I say that, there's a chance that I'm wrong. How do I find that chance that I am wrong? I place the 1.80 over there in the 1 degree of freedom. There it is. And I find the value. So what is going to be the P? So did you find it? 3, 2, 1. I'll show you now. There it is. My P, my QuiSquare stands between 0.455 and 2.706, so it's over here in this middle. That means that my P is over there. It's between 0.5 and 0.1. So that means what? That my P is smaller than 0.5 and is bigger than 0.1. That means that my P is bigger than 0.05. The probability that I am wrong is bigger than 5%. That means that if I say observed is different to the expected, there is a chance bigger than 10%, bigger than 5%, but it's actually bigger than 10%, that I am actually wrong. So observed is not actually definitively different from the expected. So I cannot say that they are different, so I say that observed is similar to the expected. And if the observed is similar to the expected, that means that there is no positive or negative association. That means that in this case, the species are distributed more or less randomly. They don't prefer to be together or not at all. They don't prefer to be separate or not at all. So they have no association at all, because the chance I'm wrong when I say observed is different to the expected is way too high, is bigger than 10%. So I reject that hypothesis and I say observed then is similar to the expected. So this here is a real life example, and I'm going to give you the values. So header only, mosses only, both species together, and neither of them. This is another way of someone that put a grid over there and they counted those species. And what they found was this. They got 9 header only, 7 mosses only, 57 both species together, and 27 neither of them. What I want from you now is to do the entire steps. Okay, do everything, including checking the QuiSquare table in the previous pages to see if you say that the observed is matching the expected or not. So is observed different from the expected? If you say the hypothesis observed is different from the expected, if your p is smaller than 0.05, you can accept that. So you say observed different to the expected. If it's bigger than 0.05, then you reject that hypothesis. You say it's not different. If it's not different, that means it's similar. Pause the video now, do the calculation for all the steps. When you finish, unpause the video, and we are going to be doing together to check out your answers. Okay, probably you took a while doing this, but now let's check out to see the values. Okay, I will make the little tables here. Observed, so I have A and B. I will call species A, one of them the header, and species B the moss. Okay, I'm making the table for observed and expected, and I filled here the table. Both are present, 57, neither of them, 27. Okay, A header, so A only, 9, B only, 7. So when I found that, I hope you got a table similar to this. You calculated the total for the rows and total for the columns, and you get there 64, 36, 66, 34, and an overall total of 100. If you have those values, now you can calculate the expected. If you didn't, or if you made a mistake and your values are not matching with those over there, pause the video and calculate. And then unpause and let's check it out. Let's check it out to see if you calculate the expected correctly. So I'll do 64 times 66 divided by 100 is 42. Okay, I round to one integer here. I think that's going to be enough. And I did that 42, 22, 24, and 12. So those are the values that I found for observed. And then, if you found those values, well done. If you didn't, check your calculation again, pause the video, and then when you figure out what you did wrong, unpause the video and carry on. Once you have the expected values, now you can calculate the QuiSquare. So QuiSquare is the sum of the observed minus expected to the power of 2 divided by the expected, which in this case is going to be 6.36 plus 10.23 plus 9.38 plus 18.75. 2 decimal places are usually enough for us to do our calculations here. When I add that, I got 43.72. If you got that value or something similar to that value, because sometimes it changes depending on the rounding, well done. If you didn't, check your calculation, and after you check it, and after you figure out what you did wrong, unpause your video. So, the QuiSquare is 43.72. So what does that mean? We need that table. So we have degrees of freedom is going to be 2 minus 1 times 2 minus 1, which equals 1. And with that table, that's what we have over there. I hope you checked in the previous slides. Otherwise, you check it right now. 43.72. 43.72 puts the value over there. Put the values way beyond 10.827. That means that the P is way smaller than 0.001. So the probability that I am wrong when I say observed is different to the expected is less than 0.1%. It's much smaller than 0.05. So that means that I accept the hypothesis. I say my observed is different to the expected, so they are not matching. And the only thing missing here now is for me to say are the species positively related or negatively related with each other. So what I have here is that both present and both absent over here is much bigger than the expected by chance. So apparently, and of course, the only one species separates is much smaller than the expected by chance. So that means that the association here is positive. If I find one, I find the other one. If I don't find one, I don't find the other one. So they are positively associated. This is the QuiSquare. This is how we do it. If you use the app that we are building for analyzing statistics, we have one there to analyze QuiSquare. Okay, the test that we are going to be doing. It's all there. You just have to put your values and it calculates for you. But it's very important to understand why you are getting the values when you use that kind of computation. If you need help, just let me know and I'm going to be helping you. And here I have a final one, just for you to do the calculation. I'm put some snails. On the right here we have the label, okay? Some snails are with lighter dots and some snails have a darker dots, and they are distributed in an environment. Let me speed this up. This is the distribution of these snails in a certain environment. Are they positively associated or are they negatively associated? How do you figure it out? I'll call the light one species A, the dark one species B. I put a grid and I can now check out to see if they are positively or negatively associated. Take your time and try to find out. Oh, by the way, you have a gradient of sun here in this case, not to make things more spicy, but pause the video and calculate to see if you find if species A and B, if they are associated with each other, and if they are, is this association positive or negative? After you unpause your video, we are going to be continuing checking out your calculations. Okay, you have finished, so let's check it out, the calculations. I made a little table over there, species A only, B only, A and B together, none of them, and I counted how many were there. Okay, I have here 38 A only, 24 B only, 21 A and B together, and 21 none of them in the place. So I will put that in my little table. So I have that 21, 24, 38, 21. If I do the rows and columns total, that's what I have. And then to calculate the expected values, what I am going to be doing here is to multiply the total of the row by the total of the column and divide by 104, the overall total. So I have those values over there, and I find 25.53, 33.5, 19.5, 25.53. Those are the expected values for those four situations if they have no association. So let's do here. These are the values that I calculate using the QuiSquare value. So 0.804, 0.604, 1.038, 0.804. Those are the four values, but the QuiSquare actually is the sum. So the sum here is 3.25. What that means? So I have to go there to my QuiSquare. It's 1 degree of freedom again because I have 2 columns and 2 rows. And 3.25 actually is over there. It's between 0.1 and 0.05. Man, this is slightly bigger than 0.05. But it's bigger than 0.05. That means that when I say that the observed is different to the expected, there is a chance that it's bigger than 5% that I am wrong. So in that case, I cannot say that they are different, so I say that they are similar. So in this case, the observed is similar to the expected by chance. That means that it's similar to what is expected if there is no association. So in this case here, these two species, the snails A and the snails B, they are not associated. I hope you have understood. If you still have problem, ask, practice, exercise. Okay, QuiSquare, it's a lot of numbers, but it's a matter of exercising until you get the idea. And when you get the idea, things get easy. And after you get the idea, then there are softwares that can calculate this stuff for us directly. You don't need to be doing the calculation by hand all the time, but it's important that you understand the calculation before you ask the computer to do the calculation for you. Okay? I hope you had fun. I will see you in another class.